Hey there, classes. Welcome back. I'm going to fly through the notes here in a slightly different way today. I'm trying to use a new program, so bear with me if it's a little clunky. It won't take too long. But I wanted to show you the way the things look in class, the way we go through it. First of all, the date is always up there at the top. And we are in week 7. Now, if you look at the first, I would say 1 to about 9 weeks of school, those are the weeks where we're looking at the planet Earth and we're talking about why Earth is so great for life. When we are looking at one of our ratio assignments this week, we're going to be comparing the size and the composition of some of the other planets and find out why our planet is the one that has life on it, while it appears, at least so far, that there's life not elsewhere in our solar system. There's likely life somewhere else out there in the universe. There might possibly, you might remember, be life on one of the Galilean moons of Jupiter. Those were one of the 4 big moons that Galileo saw with his telescope, and one of those by the name of Europa happens to have a big ice covering on it that has an ocean beneath. We're looking for life there, so you guys might be lucky enough to see that in your lifetime. So again, we're just kind of looking at the entire spectrum of all the things that led up to life on our planet and the things that kind of set the stage for life. So that was the first part of the class here. Regarding the spectrum itself, the actual electromagnetic spectrum, that was the student's first in-class assignment in terms of getting this particular work done during class. So if you want to make sure that you get everything done in class today, that should be your jumping off point. And that would be an example of each of these. Radio waves, how do we see them each day? For example, communication. Microwaves, how do we use those? In other words, cooking is an obvious example, but there's also communication involved there. Infrared, we had a handout that was showing some of the animals that I can actually see into the infrared. And remember, infrared is just another way of saying heat. And we had a firefighter a couple of years ago come on by and show us a little bit in the way of infrared technology and how it helps us save people in fires, because the smoke will be relatively cool. A body that might be a person passed out would be relatively warm, and you can find a person in a burning building using that. Visible light, that is kind of a circular definition. Visible light is light we can see, and the light we can see is visible light. Now, check out these parts of the spectrum, if you will, UV, X-rays, and gamma rays. These are the ones that we can kind of consider dangerous. These are the ones that when we are looking at our electromagnetic spectrum on this side over here versus this side over here, we're going to pay particular attention this week to UV, X-rays, and gamma rays. These are the ones that can cause damage to DNA and RNA. Now, what is DNA and RNA? Well, we haven't quite got there yet, but we've been laying the stage for it. The next part of our notes looks something like this. And our notes, let me see if I can pull up the highlighter tool there. Every single day at the beginning of the week, we pull up the key terms. Now, regarding the key terms here, I'm asking students to simply define them. You can use a dictionary, you can use our green books in class, or good old Google. Also, check this out. We're including Pluto because we're doing a ratio experiment where we want to check out the relative composition of the planets in our solar system. But back to the key terms. On the key terms, first of all, it's not that much work. We've actually already had atom. We've already had compound. We've already had molecule. We've also already had isotope in a sideways sort of way. We've talked about carbon-14 dating. And so what I'm asking the students to do here is to simply go through and make sure in their notes now they have the definition of each of these in their own words preferably. This right here, this entire part of the board here, is just a recap. The recap I like to do each week, and actually on no particular day, I just want to make sure that we're going through where we've been so far. Remember, we started this year. Again, let's see if I can pull up the highlighting tool. We've started this year talking about 14 billion years ago in the Big Bang. How did we know that? Well, that led us into talking a little bit about independent and dependent variables. And when you're charting something on a graph, if it's making a straight line like that on a graph, there's a linear relationship. We can figure out how old our universe was by checking out how far things are away in the universe. And if we run this clock backward, you might remember the name Hubble. Hubble first figured out, wait a second, it looks like everything was together in the same place at the same time if we take our data and we run it backward. That's a pretty awesome extrapolation right there. From there, we went on and we're checking out a little bit about, let's try a different color on the highlighter here, the stars, the first forces in the universe brought together the hydrogen. Now, fortunately, our periodic table in our universe didn't just stay hydrogen, number one on the old periodic table. After the stars were formed by the first generation of stars, and they did the very cool thing that stars do where they exploded, all the other elements on the periodic table get made. So we're looking at now 92 elements on the periodic table, 92 elements that make everything we need for life. Moving on from there, we had a little bit of time in class just to give examples. For example of the spectrum, the students had a little bit of time to play with this device here, which we'll have some more time with. Let me see if we can highlight that in a better color. And this right here just breaks visible light into its component colors. So they were looking at the rainbow right here, basically making use of a type of light that we cannot see. We're talking radio waves there. Communication devices like this right here using, again, a type of light that is always out there. We just can't see it. So that was a good example in class of some of the things that we get to check on out. Moving on from there, this is part of the textbook reading that I wanted to go through with the students in class in terms of when you look at our CPO textbooks in class, it asks a lot of the 7th grade students. I'm highlighting down here elements, compounds, and mixtures. Right away it's jumping on in, so let me take the pen color again. It's jumping on in, talking right away about atoms. So I'm making sure that we're reviewing what is an atom, what is an element, how and why do they combine to make molecules. For example, right here, a water molecule. And if we're looking at water, we're definitely going to be spending a lot of time talking about this Mickey Mouse molecule right here. Water, the way it's put together, we haven't quite get this far yet, but we're going to be talking about why water's polarity, a little bit of plus and minus there, makes it so critically important for life. And when we're looking at the reading, one of the things in accessing the textbook, atoms, compounds, whoops, there we go, let's put that off to the side again. Atoms, compounds, and molecules. If you look at atoms, compounds, and molecules, those are straight out of our key terms. And again, a good example of why I ask the students to do the key terms each week. Moving on from there, we had a little bit online anyway of our test corrections. This was our most recent test right here. Please look for the corrections online, but when we're going through these, I'll try and fly through these as quickly as I can. But our pendulum experiment where we added mass, let me use a highlighter there so you see where I'm reading. In our pendulum experiment where we added mass to the string, what was our dependent variable? Our dependent variable, in other words, the swing of the pendulum, the time that it took, one period, depended upon the length of the string. Which of the following statements are true? Choose all that apply. The longer string means a longer period. Definitely true. The greater the mass at the end of the string, the faster the pendulum swings. Afraid not. The mass at the end of the string does not affect. That one was also true. And a shorter string in a pendulum means a longer period. That was not true. It's just that would be an inverse of what was actually true. The next one that we had, Galileo discovered through experiment that heavy objects fall faster than light objects? No, of course not. Objects of different mass fall at the same rate. That was the one he discovered. Temperature of 66 Fahrenheit would be about, this was probably the most difficult question on the quiz, I believe, asking you to apply the formula that we had. And 66 degrees is about 18.9 Celsius, or 19 right here would be the answer. Which of the following best represent the most important elements for life? This is question number 5. Again, we did this one in class several times, but it's easy to remember as C-H-O-N, good old Chon. They're mixed up in order here, which is on purpose, of course. But as you'll check out the mix up in order, which one gives us C-H-O-N-N, carbon, hydrogen, oxygen, and nitrogen. That looks like it's B right there. And let's go back to a highlight color, the periodic table of element groups, elements with similar characteristics together, elements with similar tastes, similar names, elements together that were discovered at about the same time. Nope, that would be elements right here. Elements with similar characteristics are grouped together. Moving on to the next part of the page. Let's see if we can pick up a highlight there. Again, I'm getting used to this program just a little bit. Of the states of matter that we studied in class, the 4 states that we studied in class, the least amount of kinetic energy and the most amount of kinetic energy would be solid, liquid, gas, and plasma. That would be D down here. Moving on to atoms right here. Atoms that combine to form molecules this way lose or gain electrons and stick together because they have opposite charges. The atoms become ions. The example that we went through in class quite a few times on this one, it was NaCl. Na being a metal, remember, never date a metal because they are losers. They lose an electron, become positive. Cl gains an electron, becomes negative, and they end up sticking together because of, see if I can draw that correctly, sticking together because of opposite charges attracting. If I'm looking right here, the 4 known forces in nature are, this is again going way back to the beginning of class, why atoms get together in the first place. We've got gravity being one of them, of course, the weak force, the strong force, and electromagnetism. That would be A in this version of the test. In the equation, density equals mass over volume. So there you go, volume is our answer. V stands for volume. And finally, conversion factors. We're going to be doing a lot more of those this year. They are, remember, in your math classes across the hall. Let's see if I can draw it correctly here on the side. The big one is the way they always draw them in the math classes, those CPM books over there. And we're looking for, it says there's more than one answer, 100 centimeters per meter. We've had time in class to use that quite a bit. And if you look at 1,000 meters in 1 kilometer, that was also in other words, these are fractions where if you have 100 centimeters over 1 meter, you've got yourself really a giant 1. It really means the same thing on top and on bottom, the numerator and the denominator. It's just a different way of writing the same value. 1 yard, 10 feet, afraid not. That is not one of our conversion factors. And then finally, moving on here to the last part, I believe that was it. Oh, I had one more page. There we go. One of the things that we're going to be going into this coming week is why you have 2 atoms that will decide to stick together. And one of our examples of this one was hydrogen. Hydrogen is a slightly different reason that they stick together rather than the NaCl. In the case of hydrogen, you've got an electron, and you can kind of think of the electron as zipping around so fast when it's going from one to the other, that it's essentially helping hold this together. When we're looking at a water molecule, that water molecule is being held together by an electron, actually sharing electrons, that are zipping around so fast that it's holding these atoms together. So you have one separate atom right here, hydrogen, another separate atom right here, hydrogen, and yet another separate atom right here, oxygen. And when you're looking at these, this is a covalent bond. We're going to learn all about these, why these particular ones stick together, and why it's slightly different than the way that NaCl, an ionic bond, sticks together. So there we go. That's where we left it today. That's where I'll leave this version of the notes. Again, just trying to hit the notes in a slightly different way. And I will see you in class. Take care of yourself and get those definitions